Uh, Hello student, today I am going to discuss you the problems of longest common subsequence. Longest common subsequence is the dynamic programming based technique. First of all, the name shows that this find out the common sequence between the two strings. But this common sequence is not as simple as we find out in day-to-day life. For example, in India you may find out in, but in this we find out the common sequence between two strings, but basically this is used to focus in genetic engineering. In genetic engineering, we try to match the percentage, find out the percentage of match between two genomes. And in this, we particularly find out matching not on the basis of continuity, but just on the basis of the common components. If it is not clear to you, then I am going to take an example with which help of which I shall explain you. Suppose this is a string BCA, BCDA. BACD. Suppose this is a string 1. This is a string 1 and this is a string 2. In general terms, when we match two strings, we find out how many components are common with each other. In general concept, we will say that AB and AB is the common sequence. I think AB and CD are the two match. CD occurs here, CD occur here. Here we are matching AB and AB, but the longest common sequence is not that simple kind of matching. In this, when we match two numbers, we find out the common sequence, but they need not to be continuous. For example, here a string, I am relating that A, B, C, again B, C, D. It means out of these two, A, B, C and B, C, D would be the longest common subsequence. This may appear very strange to you, how I am matching a number C with a number that is next to D, which is not in the same order or in the same position, as in this C occurs here at third position, but C occur here at the fourth position. But I am considering this as a match. And here B is the fifth element in the first string, B is the fifth element in the fifth string. But C here is the sixth element in the first string and seventh element in the second string. But I am considering that as a match. Why I am considering this? Because when this is, I have told you that this is used in the genes matching of genes. And when genes mix, then the certain components of the genes attached with the different genes from another persons. So in this way we find out how many commons genes are common in between, where we do not consider that the matching portion should come in at the same corresponding position. If it's one is coming at the third, next is but in second position the same alphabet or same gene is occurring at the position different from that, then it may be considered as a match. So here this is the longest common subsequence. There may be multiple longest common sequence, and with help of dynamic programming we would be able to find out each possible longest common subsequence. Normal human do not match two strings like this, but this kind of matching is done with help of computers, where they can find out how much genes are matching with each other. On the basis of this longest common subsequence, we say that the chimpanzees are closest to the human, and there 90% of around 90% of genes, not exactly I'm knowing the 90 or 80% of genes are very much similar to the humans. This is done on the basis of longest common subsequence. So now I am going to tell you that how this is done, because there are thousands of genes, so it is not easy to match just by taking a look. So this is the question which is can be dealt only with help of dynamic programming to get the all possible solution with the possible solution. So this is the concept that alphabets may come at different position and may do not occur in consecutive order. So even then they are considered as match. Only the string should be present. So this is the concept of longest common sequence. And how it is done with help of dynamic programming, I am going to discuss you. First I am going to write the algorithm, and then I shall discuss you the algorithm. After that I shall give you the shortcut form with help of which you will be able to do this, and in the this. Okay, so I'm just rubbing this, and after that I'm writing the algorithm. I'm going to write. First I shall write, then after I shall explain it to you. N xi is equals to yi. Okay, then okay, right. This may appear a little bit complicated to you, but when I shall explain it to you, this will be very simple for you to solve a problem of longest common subsequence. And you could verify also after completing the questions. So you will be able to verify the answer with help at the end. Here, when we try to match two strings, then suppose there is a string m, first string is called as x, second string is called as y. Then m is the length of string x. There are two strings on which we shall perform matching. The first string is x, second string is y. The length of the first string is m and length of the second string is n. Okay, so there are two string, x string with length m and y string with length n, right? After that, what we shall do, first we shall, for I is equals to 1 to m, do ci comma 0 is equal to 0. Then we shall create a matrix like a structure on a matrix of size m cross n. We shall create a matrix of size m cross n, where m is the length of first string and n is the length of second string. After creating the matrix C, okay, the C matrix, what we shall do in this C matrix, for I is equals to 1 to m, means for the length of, we shall write a one string or along the m length. Since the first string x has a length m, so we shall write one dimension of length m and we shall write down the alphabets of the string x, and across the dimension of length n, we shall write the alphabet of the string y. Okay, so one string will be written along the column side and one string will be written along the row side. Okay, after writing this, there will be a matrix of m cross n size. What we shall do after that? After that, we shall, for I is equal to 1 to m, then for along the length side, suppose m is the row side, for the length we shall place ci 0 is equal to 0, means for each value of I from 1 comma 0, 2 comma 0, 3 comma 0 and up to m comma 0, we shall place the value 0. Okay, 0 means for the first row element would be the 0. Similarly, for j equals to 0 n, means 0 comma 1, 0 comma 2, 0 comma n tak, means for the first column entry would be 0. In simple word, we can say that first row would be 0 and first column would be 0. After that, for I is equal to 1 to m, for filling up the next the other position of the matrix, what we shall follow three rules. First rule is that if corresponding to an element or alphabet of a string, if there is a matching alphabet in a position, means when for I is equal to 1 to m, if across the length of first string and for across the length of j is equal to 1 to m, length of the second string, if there is a condition when xi is equal to yi, means if two alphabets match together, in that position, what we do, we fill the values Cij is equal to Ci minus 1, j minus 1 plus 1. We fill in place the value that is filled at the diagonal position, that is the value 1, that is the value filled is equals to the value I minus 1, j minus 1 is the diagonal element. Definitely, if our position is ij, then I minus 1, j minus 1 will be a diagonal element. Then that will be equal to I minus 1, j minus 1 value plus 1. And in each matrix, we shall fill two vectors. First, C value, and along with that, we shall place an arrow. Bij, this is the tilted arrow symbol. So, whenever there is a match between xi and yi, we shall fill the value Ci minus 1, j minus 1 plus 1, and we shall place an arrow that is tilted at that position. If there is no match, then what we do? Else, if in that situation we check out that if I minus 1 comma j is greater than or equal to, is symbol, pay attention here that the symbol is greater than or equals to I minus 1 comma j is greater than I minus I comma j minus 1. If I minus 1 j will be the element in the one position, one behind, and I comma j minus 1 would be equals to 1 position upward. I shall design the matrix with help of which here you write understand that concept. I minus 1 comma j, if greater than I comma j minus 1, in that position which one is greater, that will be placed there. if I minus 1 comma j is greater than I comma j minus 1, then Cij equals to Ci minus 1 comma j. And else, if it is not so, then Cij is filled with Cij minus 1. Simply, in that situation, we compare two numbers, Ci minus 1 comma j and Ci comma j minus 1. Which one is greater than other, that is placed in the Cij. And if they are equal, or Ci minus 1 comma j is greater, then the arrow symbol is upward, in upward direction. And when the Ci comma j minus I comma j minus 1 is greater than Ci minus 1 comma j, then in that situation the arrow is in placed horizontally like this. So this is the simple algo, but to clearly understand, uh, and instead of remembering all these difficult steps, I shall just write some simple step or formula with help of which you can solve this algorithm with much confidence and easiness. So I am going to write the simple version of this algorithm with help of which you will be able to solve the numericals. C j minus 1, sorry, if j is greater than 0 and xi is not equal to yi. This is the simple version of that algorithm. This is the saying the same thing that algorithm was defining, but this is the simple form or expression of that algorithm. Here, when I is equal to 0 or j is equal to 0, means if in the first row and first column you shall place 0. In the first 4-5 lines, when I is equals to 0 or j is equal to 0, then Cij is equals to 0. The matrix position for first column and first row will be 0. And if there is a match between alphabet, xi is equal to yi, means was element of the first string is matching with the element of the second string. In that situation, ci, the value of cij would be equals to value that is at the position ci minus 1 and j minus, that has been already calculated, ci minus 1 and j minus 1 plus 1. Then in that case, Cij value would be equals to the one more than the value that is stored at the position Ci minus 1 and j minus 1, right? And when they are not matching, when xi is not equals to yi, in that situation, the value of Cij would be the maximum of the values stored at position Ci minus 1 comma j and value stored at position Ci comma j minus 1. So in that situation, it compares the two values. Which one is the greater one? That is placed at the position of Cij. Comparison is being done between Ci minus 1 and Ci comma j minus 1, and which one is greater? That is placed at the position Cij. If the this condition is comparison is done when xi is not equals to yi. When xi is equals to yi, in that situation, this value is 1, Cij value is 1 greater than the value stored at position Ci minus 1 comma Ji minus 1. So this is the basic of longest common subsequence. So before filling or solving a numerical, you should be thorough with this formula. After that, we will be able to solve this question. So okay. So after this, I shall take an example with to solve the question. Okay. So now in the next lecture, I shall take an example lecture, and after which you will be very clear to understand all this. So thank you. Hmm. Okay. Stop recording.